Hi, my name is Sachin Alex and I'm part of the technical marketing team at VMware. In this video, we will see what constitutes an alert in VMware ARIA operations, how they are generated, customizing the out-of-box alerts, and creating notifications using different outbound methods. The main component of an alert is the alert definition. It defines and describes the alert. Symptoms trigger the alert definition. Symptoms are conditions where objects are evaluated based on metrics and properties. If they are in a particular state or a particular threshold is reached, then they trigger the symptom to be true. Multiple symptoms can also be bundled into an alert definition. Recommendations show ways to fix the triggered alerts. They can also contain automated actions to fix the issue. Here, in this example, you see an alert that has been generated on the selected object because the CPU usage value has exceeded the threshold value of 100%. Recommendations on the possible next steps have also been given. Once the alert is triggered, it is important that the user knows it has occurred. Users get to know this using notifications. You can configure a standard email configuration for users, letting them know an alert has triggered. Slack integration can also be done in order to let the entire team know about the issue. Native integrations with ServiceNow can be leveraged so that incidents can be raised and further narrowed down to the team of origin. Webhooks can be used to integrate literally anything that accepts REST API calls. Finally, we can use SNMP traps or just write it to a log file, which can then be used in ARIA operations for logs or any similar product. The Alerts tab is present under the Troubleshooting option in the navigation pane. Here, you can see all the alerts that are listed by VMware ARIA operations. The default view has the following tabs. Criticality. Based on the severity of the alerts, alerts can have following criticality values: critical, immediate, warning, and info, with critical being the most important one and the one that needs to be targeted first. Alerts can also be categorized as health alerts, risk alerts, and efficiency alerts. The health alert affects the health of your environment and requires immediate attention. You use the health alert list to evaluate, prioritize, and immediately begin resolving problems. Risk alerts indicate risk in your environment. You address risk alerts in the near future before the triggering symptoms that generated the alert negatively affect the health of your environment. Efficiency alerts. The efficiency alerts indicate problems with the efficient use of your monitored objects in your environment. Address efficiency alerts to reclaim wasted space or to improve the performance of objects in your environment. Alerts can be grouped on the basis of time, criticality, definition, object type, and scope. If you select time, you can see alerts grouped on the basis of various time parameters. If you select criticality, you see that the alerts are classified under critical, immediate, warning, and info. When you select an alert in the Alerts tab, there are certain actions you can perform on it. Canceling an alert and then deleting it causes the alert to be removed from the Alerts tab. If the underlying condition is still true, the alert pops up back again. The correct way to remove an alert is to address the underlying condition that triggered the symptom and generated the alert. If you want a particular alert to not show up on the screen for a certain amount of time, you can suspend it. You need to mention the number of minutes for which you want it suspended. You can also take ownership and assign alerts to certain users. You need to mention the username. When you click on this CPU workload related issue, It takes you to the detailed page of the alert. Here, you can see that the symptoms for which this alert has been triggered is true. VMware ARIA Operations provides recommendations to rectify the issue. It tells us to check the applications running on the virtual machines in the cluster to determine whether high CPU workload is an expected behavior. There are other recommendations to rectify the issue on similar lines. When you select the Related Alerts tab, you see recurrences of this alert on this object in the last 30 days. You can also check if these alerts have occurred on peer objects or on objects in the related scope. When you select Potential Evidence tab, you see metrics and you can analyze it for objects in the related scope. Now, we will be editing an out-of-the-box alert. As stated earlier, it is best to clone an existing alert rather than work on it directly, as we tend to lose the changes made during a product update. Using a naming convention helps to differentiate the custom alerts from the out-of-the-box alerts. We define the base object type on which the alert impacts. In our case, we keep it at cluster compute resource. In the advanced settings, we can define the kind of impact, criticality, and the alert subtype for the alert that we are working on. We'll keep the wait cycle at 1. This configuration ensures that after all of the symptoms are triggered at the desired symptom sensitivity level, the alert is immediately triggered. This setting helps you adjust for sensitivity in your environment. We'll also keep the cancel cycle at 1. This configuration ensures that after all of the symptom conditions disappear, after the desired symptom cancel cycle, the alert is immediately cancelled. In the Symptoms and Conditions tab, you define when the alert will be triggered. In this case, there are 2 sets of conditions defined. The alert can be triggered when either of the symptoms is triggered or all the symptoms are triggered. In our case, we set it as all. You can add an additional symptom or condition. We will be adding a condition where if the CPU workload exceeds 70%, an info alert will be triggered. In the Recommendations tab, you define recommendations for the triggered alert. If there are more than one recommendation, you arrange them by priority. In the Policies tab, you can select the policies on which the alerts will be active. You can customize the symptoms or conditions for different policies. Now, we will be sending the alert notifications that are generated to Microsoft Teams. For that, we will first have to configure the Teams channel on which you want the notifications to come and create an incoming webhook. We will be naming it as follows. A channel needs to be created within this team where the alerts will pop up. For configuring the incoming webhook, we use the connector option. We first add the incoming webhook and then configure it. You give an appropriate name. You can also change the image of the incoming webhook. In our case, we keep it as default. And there it is. We have the URL generated for the incoming webhook. We will copy the URL and go back to the AriaOps page to configure the AriaOps outbound notification plugin instance. We use a familiar naming convention. We will be configuring the notification for all the objects. Here, we need to create a new instance for the webhook notification plugin. The URL that was generated in Teams will now be pasted here. A point to note here is that the test won't work at this point as it is sending a default payload which gets rejected by Teams. So using a payload template that is provided by Microsoft Teams or the app provider is essential. Once we have created this, we wait for the fresh alerts to pop up. Once they do, they will automatically appear in the Teams channel that we created. On similar lines, you can also create standard email notifications if you have the SMTP host details and port details. In conclusion, what we've seen in this video is how we can create alerts and what constitutes an alert, customizing out-of-the-box alerts that are present in ARIA operations, and finally, creating notifications for these alerts.